In this section, we will discuss a method for solving systems of linear equations called by elimination. Actually, it's called Gaussian elimination, according to the German mathematician Gauss. He was the first one to use this method. He developed this method. The method we learned in 7.4 by substitution is an excellent method, except when you have to solve higher order systems. For instance, if you want to solve 4 equations in 4 unknowns, it becomes very cumbersome. It will work okay if you are solving systems of 3 equations, 3 unknowns. But for higher order systems, it becomes very cumbersome. The main problem with that method is that it's not suitable for programming. Because in real life, when you solve systems of linear equations, you are interested in very, very large systems. I have solved myself. I have had to solve systems of 1 million equations in 1 million unknowns, and I have seen people in the automotive engineering industry where they have to solve systems of 5 million equations in 5 million unknowns. And that can be done using elimination. You can program the method, use whatever language, C++, Java, and then you can easily, not easily, but you can solve very large systems. And this is the method that is used in real life mostly. So we will learn how to solve linear systems by Gaussian elimination. And there are few steps that we need to do in solving such systems. Okay, so we have basically 3 operations. Operation 1, you can that operation might not be very will not seem very helpful if you are working with systems with systems of only 2 equations, 2 unknowns. Okay, but I'm gonna say it anyways, and it's an extremely simple, intuitive step. You can interchange any 2 equations. Interchange any 2 equations of the system. Okay, so for instance, equation 1 becomes equation 2, and equation 2 becomes equation 1. So that's very intuitive. It's like you have 2 persons. One is Abdullah and the other is Abdulaziz. So you can say Abdulaziz and Abdullah, or you can say Abdullah and Abdulaziz. Still the same 2 persons. So interchanging 2 equations is very intuitive. Doesn't change the solution set. The idea is, when you are solving very large systems, one of the steps could be very useful. The steps of interchanging 2 equations. The second step, which also intuitive to some extent, we mentioned that before. You can multiply any equation. Multiply an equation or any equation by a non-zero constant. Okay, as long as you're multiplying the entire equation, the left side of the equation and the right side of the equation. If you multiply by 0, you simply get 0 equals 0. So you are losing information about the system. That's why we want the constant to be non-zero. And the third operation is can take one equation, multiply the equation by a constant, and add the resulting equation okay, I'm gonna continue here. Add the resulting equation to another equation. Then you replace the final equation you get. You replace this other equation by the resulting equation. So the idea of the third operation depends on two steps. Okay, let me explain it over here. So let's say you have an equation. So you have x minus 2y equal 3, 5x plus y equals 1. Okay, there are two steps here. The first step is that if you have an equation like this, you can add the left side to the left side and the right side to the right side. Okay, so 5x plus 6x x plus 5x is 6x minus 2y plus y, because we're adding and subtracting like terms, so that's minus y. So this is the left side, and the right side, 3 plus 1 is 4. All right, so that's okay. The resulting equation is an equivalent equation. Now, what you can do is, let's say you can, before adding the two equations, let's say you multiply the second equation, or let's multiply the first equation, it's the same, okay? You multiply the first equation by minus 5. Okay, exactly why minus 5? Because minus 5 is the opposite of 5. So when I add, the x variable disappears. So this reminds us of substitution, where you get rid of one variable. Okay, so the first equation becomes minus 5 times x. Of course, you have to multiply the entire equation by that constant. Minus 5 times minus 2y. And never forget to multiply the right side. Minus 5 times 3, minus 15. Now what do I have? I have this system of equations. Now if I add the two equations, what happens? 5x plus minus 5x is 0x. Y plus 10y is 11y. Add the right side. 1 plus minus 15 is minus 14. And as you can see here, we have an equation that has only y in it. So you can easily solve for y. And then you can do the same thing for x. You can get rid of y instead of getting rid of y and get x. You can do the same thing, or you can go back and find x from either one of the two equations. All right, so the elimination method. As an algebraic method that depends on the addition property of equality can also be used to solve systems. Adding the same quantity to each side of an equation results in equal sums. So here it's like you are adding one equation to another. So It's like generalizing this rule to using equations, adding equations to each other, adding the left side to the left side and the right side to the right side. Okay, so here they're saying instead of adding the same quantity C, we add two different quantities, but they are equal. Right? If we know that C equals to D, right, I have A equals B and C equals to D. I can add C to the left side and I can add D to the right side. So this is what I did over here. Right? I added to this side, I added this, and I added to this side this. So instead of adding the same quantity to this second equation, okay, to the left side of the equation I'm adding this, to the right side of the equation I'm adding this, because these are equal. All right. So that's the justification of that procedure. All right, here they did not talk about multiplying the equation by a constant, but it's the same thing. We know that you can always multiply an equation by the same constant. Solve the system of equations by elimination method. So here already the coefficients of y in these two equations are opposites, additive inverses, so that if you add them, y will vanish. So we simply add the left side to the left side. So 3x plus 2x is 5x, and minus y plus y is 0. So this is here 0, y. And then you add the right side to the right side, which is 10. So from this equation, y is eliminated. Okay, that's why we call this the elimination method. Y is eliminated, and you can easily solve for x. We got x. To get y, you substitute this value of x in this equation or in this equation, doesn't matter. Or you can do the same thing, okay, same procedure, eliminate x instead of eliminating y. But here in this case, it's not easy to, it's easy, but it's not as easy to eliminate y, because you want to eliminate x, I mean. To do that, okay, I'm going to do it this way. Here what they did, I'll let you follow this. They used equation 2 to find x, to find y. Used equation 2 to find y. So instead of x, they used 2, its value, and they found y. What I will do is I will do the same thing we did to y here. We will eliminate x and get y. To do that, we need the coefficients of x to be opposites, to be additive inverses. Right? What we can do to do that is we can multiply this equation by negative 2. Equation 1 by negative 2. So you have negative 6x. Negative times negative is plus 2y. Negative times 7 is negative 2 times 7 is negative 14. Okay, so multiply both sides of the equation by negative 2. Now, multiply both sides of this equation. Okay, we multiplied by the negative of this, the first equation. Multiply the second equation by 3. Not negative 3, because we want the coefficient of x in the second equation to be plus 6. So multiply this equation by 3. So 3 times 2x is 6x. 3 times y is 3y. and 3 times 3 is 9. Okay, now we have the coefficients of x are opposites. Add the two equations. Minus 6x plus 6x is 0, plus 2y plus 3y is 5y. Add the right side. Minus 14 plus 9 is minus 5. So we eliminated x the same way as we eliminated y over here. So y is minus 1. The solution is 2 minus 1. This is the set of ordered pairs, and there is only one ordered pair. So now this is the procedure. Write both equations in standard form. First, transform the equations as needed so that the coefficients of one pair of variable terms are opposites. Multiply one or both equations by appropriate numbers so that the sum of the coefficients of either the x or the y terms is 0. Add the new equations to eliminate a variable. The sum should be an equation with just one variable. Okay, so another way of stating these is the three operations I mentioned before. Okay, except the interchanging of two rows, because we don't need that if you are working with only systems of two equations and two unknowns. If you work with 3 and higher, then this operation becomes very, very useful. Okay. Solve the system. First, put the system in the standard form. So we have x plus y equals 2. That's equation 1. Equation 2 becomes 2x minus y equals 10. Now, we don't need to multiply because these two variables have opposite coefficients. So just add equations, the two equations, and we get 2x plus x is 3x plus minus y plus y is 0 equals 12, which means x is 12 over 3. Okay. Now we get y from this equation. So y equals 2 minus x equals 2 minus 4, y equals minus 2. So the solution set is 4 minus 2. The set of 4 minus 2. Okay, so this is something, this is what I mentioned before. Sometimes you cannot just add the two equations to eliminate one of the variables. You need to multiply, and I already did that. So let's have an equation, have an example. Now you could eliminate x or y. It's up to us. So let's eliminate x. To do that, we multiply let me eliminate y, because here we already have a minus sign. All right, so I multiply this by 5 because we have a 5 here, and I multiply this by 2 because we have a 2 here. So 2 times equation 1 will give 2 times 4x, 2 times minus 5y, 2 times minus 18. So this is the new equation 1. Multiply equation 2 by 5. So 5 times equation 2. 5 times 3 is 15x. 5 times 2 is 10y. 5 times minus 2 is minus 10. So that's equation 2 prime. Now we add 15x plus 8x is 23x plus minus 10y plus 10y is 0 minus 32 plus minus 10 is minus 42. So x is minus 42 over 23. We use equation 2 to find y. Okay, 2y equals minus 2 minus 3x, or y equals half minus 2 minus 3x. So y equals half minus 2 minus 3 times x. X is this. So minus 42 over 23. Changing those to make sense. Half into minus 2 plus, so that's 126 over 23, or half, well, let me multiply this out. So this times this is minus 1, and this times this, you divide the 126 by 2, so that's plus 126 63 over 23. So this is equal 23 minus 23 plus 63. So this is 40 over 23. So the order per is x is minus 42 over 23 and y is 40 over 23, and that's our solution. Okay, so I already did that. Alright, so you could eliminate x or eliminate y. Don't forget to multiply both sides of the equation by the constant. Sometimes it's easier to find the value of the second variable in the solution using the elimination method twice, using it again. Okay, like I said before. Alright. Solve the system. Alright. Now, write it in standard form. So you have minus 4x plus 3y equals 8, 6x plus 2y equals 9. Now, we can eliminate x or y. So let me now eliminate y. Okay. So I multiply this equation by minus 2 because this is 2. So equation 1 multiplied by minus 2. So that's 8x minus 6y equals minus 16. Multiply equation 2 by 3 because this is 3. So 3 times 6, 18x. 3 times 2, 6y equals 3 times 9. As you can see, now these will cancel out. So the y is eliminated. Adding the two equations, 26x plus 0 equals 11. So x equals 11 over 26. So now we got x by eliminating y. So what I will do is to find y, I will eliminate x. So going back to the same system. Okay, so you have minus 4x plus 3y equals 8. 6x plus 2y equals 9. Okay, we got x here by eliminating y. We will get y by eliminating x. Eliminating x means these must have opposite coefficients. Okay, so you have minus 4 and 6. We don't need to multiply by minus. We just need to make the coefficients have the same magnitude. So if you multiply equation 1 by 3, equation 1, multiply equation 1 by 3. So 3 times minus 4 is minus 12x. 3 times 3y is 9y. 3 times 8 is 24. To get 12 here, we multiply the second equation by 2. Multiply the second equation by 2. 2 times 6x is 12x. 2 times 2y is 4y. 2 times 9 is 18. Now we add. This is 0. 9 plus 4y is 13y equals 30, 42. So y is 42 over 13. This is the x. This is the y. So we used elimination twice. First time we eliminated y to find x. Second time we eliminated x to find y. Okay. Let's see what kind of special system is this. If you look at this second equation, it's really minus 2 times the first equation. Just multiply the first equation by minus 2. You get minus 4x minus 2 times 5y minus 10y equals minus 2 times 1. So this is the second equation. So really what this says is that the second equation is actually the first equation in disguise. So we have infinitely many solutions. What we will end up with is the second equation is really 0 equals 0. Alright, so the solution, okay, if you want to do it as before, multiply the first equation by minus 2. So what do we get? Multiply the first equation by minus 2. We get minus 4x minus 10y equals minus 2. Now add these two equations, you get 0 plus 0 equals 0. So the solution is the set of all xy such that 2x plus 5y equal 1. Infinitely many solutions. Any x, y per that satisfies this condition is a solution. Okay, any xy pair that satisfies this condition is a solution. Now, of course, you could state that it should satisfy the second condition, but like I said, it's the same, except this is a simpler form. So basically, this is a straight line, as you remember. Okay, it's a set of all solutions, and the graphical solution is this is where you have the same straight line. Okay, you have two straight lines that are on top of each other.